Welcome and thanks for joining me. This video offers some best practices for how to create and populate a new Hydro GeoAnalyst project with a lot of data in a short amount of time. The first step is to make a new project. You can choose between a full SQL Server instance, which is great for organizations where multiple users will be working with and sharing the database, or you can use a local database, which is perfect for small individual projects. For this demonstration, I'll be creating a local database just to illustrate some best practices, but the steps that I'm showing you work exactly the same for both configurations, provided that you have the proper permissions to create a new database instance on the SQL Server that you're working with. If you aren't sure, you should check with your company's IT contact. So first thing, I need to give the database a name. Now I need to pick which database template I would like to use. This template determines which tables and fields will be created in the database and how they relate to each other. Hydro GeoAnalyst comes with two standard data templates, one that's in metric units and one that's in imperial units. We recommend starting with one of these templates. You can edit the template anytime during the life of your project to accommodate any special tables or fields based on the needs of your projects. And you can also save the edited database structure to create your own standard template that members of your organization can then use to create new projects of their own. For this project, I'm going to use the metric template. Next, you have to choose your projection. The site data I'm working with today is recorded in UTM and it's in Kitchener, Ontario, so I'll map to the NAD 83 Zone 17 North projection. UTM, NAD 83, Zone 17 North. HGA will then take a few seconds to create the database and build out the tables and fields based on the template you selected. Adding data to a newly created database can be one of the most frustrating and challenging parts of any database project. Fortunately, Hydro GeoAnalyst comes with some tools that will greatly speed the importing of new data and hopefully remove some of the frustration. Here are the data that we're trying to import. A set of stations, some lithology data that was recorded during the drilling of the stations, some water level measurements, and some lab data. The first thing we're going to do is import the station data. Because station data contain X and Y coordinates, which are associated with a projection and a datum, they need to be handled separately from other data types. Here you can see the data that we're working with. We have station names, the X and the Y UTMs, a ground surface elevation, a top of casing, a marker to indicate the type of station, whether it's a borehole, a monitoring well, or a soil boring, and the date that the well was drilled. We will import these into HGA by clicking on the Data Import button. We'll use the General Import feature, which is for station data. We will pick the file. We then have to tell HGA that we would like to import that set of data into the location table. Fields shown in green are required. Everything else is optional. Click Next through this. You can see a preview of the data as you've mapped it, and then we can complete the import. And now you can see all of your station data inside HGA. The rest of the data that we would like to import, the lithology, the lab data, and the water level data, all relate to these tables and fields in HGA. Now, there are other fields in many of these tables, but the ones that I'm not showing are optional fields. What I've done is list the key fields in the tables that absolutely must contain data in order for the records to make sense. It's a good idea to look over the fields and tables in your database and make sure that you understand the requirements and which fields must be populated, so that if you need to, you can make any adjustments to the data structure before you start trying to import data into the database. So two of the fields that we're working with, the soil type shown here, and the chemical, which is the chemical name that's shown here, are standardized on a set of lookup lists in HGA. This is important because this means that any values in your data that don't identically match what HGA is expecting in these fields will not be imported. So that our setup of this new project goes smoothly, we're actually going to make two adjustments related to these fields in the standard template, and this will greatly simplify the initial project bulk data loading. So the first adjustment we're going to make is on the chemical name. We will adjust this by opening the template manager, which is this button here. We will expand the tree until we locate the chemical name field, which is under monitoring event and parameter results and chemical name. And we will set the list type to optional instead of required. This means that when importing or typing in data, we can either pick values from the list if we want, or we can add brand new values. So let's save this change by exiting. And the project will now be reloaded to take into account that change. The next adjustment we're going to make is on that soil type field that I had shown. We could follow a similar set of steps as we did for the chemical name definition, in that we could change the list to optional and allow any values to be added to this field. However, instead, I'd like to show you an alternate approach, one which will also work for the chemical name if you like, and it's by far the better approach because it enforces consistency in the values to guard against things like typos or alternate spellings, such as things like leaving commas or hyphens out in chemical names. But in particular for the soil type, because images are associated with each soil type and those images are used to create both well profiles and cross-section graphics, it is important that Hydro GeoAnalyst has images linked to each soil type. So, because I have all of my lithology data all together in one spreadsheet, I have the nice ability to quickly pull out a list of all of the unique soil type values. And I can use these to create a new material specification definition in HGA. And I can use that then to make a soil type list that exactly matches my project data. So that's what I'm going to do now. I'm going to select all of the soil type records from my Excel sheet. I'm going to open a brand new Excel sheet, and I'm going to copy this column and paste it into the new sheet. And then I'm going to use the data options in Excel to remove duplicates. So it's now cleaned up and it's found that I only have these 8 options for soil type. I've started, granted, in this example with a very clean project data set. In reality, you'd probably see some typos and some variations, and this might need some cleanup itself before you import. But for our purposes, we now have a clean list. So I'm just now going to make 2 final changes, and I'm making these changes so that this file format will be compatible with the import expectations for the material specification editor in Hydro GeoAnalyst. First, I need to change the header for this column, and I need to label it name, and then I need to add a secondary column called image. Now, it is important actually that these headers have the identical titles that are shown here, including the capitals. So this needs to be name with a capital M, and this needs to be image with a capital I in order for the import to be successful. Once I've made those changes, I can go ahead and save this, and I need to save it to a comma separated, otherwise known as CSV format, shown here. And I'll keep the name soil type. There we go. Now I can close this and jump back to Hydro GeoAnalyst. In Hydro GeoAnalyst, I will open the material specification editor. And what I want to do is make a new material specification. Let's call this Kitchener. Now I can use the import function and I can open the soil type list that I just saved out, and they come right into the program. At this point, you can choose, if you like, to associate images by double-clicking on the image field for each of the materials that we've defined. I won't show that in this example, but that is highly recommended, as I said, so that the borehole logs and the cross-sections display correctly. Once I'm satisfied, I can save this new definition, and when I select it, to set this as the new default specification for this project. Now, when you're working through on your own, you may find it advantageous to either create a new material specification for each project you work on, or you may find that you want to standardize either your office or your organization on a specific material specification definition for your group, and use that on every project. Now, the best approach for getting a lot of new data into a Hydro GeoAnalyst project quickly is by using an EDD template. An EDD template gives you two big advantages over general imports. First, it gives you a list of all of the fields available in each table, and it automatically maps each of these during the data import step so that you don't have to worry about doing that mapping by hand. And second, it will visually validate and highlight any potential problems with your raw data before you try to import it, so that makes it easier to catch and correct errors sooner. To create an EDD template, we need to open the EDD template designer, which is right here. Because my goal is to bulk import the data as part of the initial project setup, I'm going to add whole tables to the EDD template, one table for each type of data I have. Now, this description add-ins table stores station-related information. I'm going to include it by selecting the table name and using this blue arrow. If I expand the description add-ins node, you can see all of the fields in this table. Now, I'm including this table because in our station data, we have the date that the wells were drilled, and we want to be able to import this installation date here. I will also go ahead and I will add the lithology table because we have a lot of lithology data. And under monitoring event, I will add the water level table, parameter sample, and parameter result because those will handle our lab data. Let's save this template. Now we are ready to open the quick checker. In the quick checker, I want to make a new file and I want to use the EDD template that I just created. Now you can see in the quick checker, it's added one tab across the top for each of the tables that I had included in my EDD template design. Now I'm going to do something a little bit sneaky. I don't know about you, but I spend a lot of time in Excel and I can do things in Excel much faster than in almost any program. I'd like to take advantage of that, and I can. I can do this by exporting this quick checker format into a blank template in Excel. And I can use that blank Excel template to structure the data so that the importing process therefore becomes really simple. So under Tools, there's an option to export to Excel. I'm going to do that, and I'm going to call this my quick checker data file. The quick checker will prompt me to tell me that it has saved it and ask me if I want to open it. So I'll pick yes. And now I have this nice Excel template where each worksheet is one of these data tables that I need to populate. Now what I'm going to do is open up all those separate Excel files that I had that contain my raw data, and I'm going to transpose all my normal project data files into the template shown here that I just created, just by copying and pasting data rows and columns. Let me show you what this would look like for the lithology table. So first, if I open my lithology data, very nicely I have station name, from, to, soil type, and a description. And if I look at the template under the lithology, it wants station name, a depth from, a depth to, a soil type, a description, and there's 2 extra fields called color and odor. Now I don't have those, but I can just ignore them because they're kind of optional. So what I will do is I will select all of these records. Nicely in this example, I have them formatted in the exact column row format that this template is expecting. But if this was your normal project data, you might not have it so easy. But you can kind of work through the template, and at least this way you know all of the fields that are available to you, and you literally just have to map the data in. If I look at the station data, here's this date drilled field. So what I really want is the station name listed here, which I will copy into the station name field. And then the only other one I have is this column here, this installation date, which is the date drilled. So I can just copy and paste that in here. Now if I jump to the groundwater level table, it's expecting station name, a screen ID, a date that the water level was measured, and a depth to water level. And I've got options for a dry indicator if the well was dry, and a comment if there was something special noted about the well. So this screen ID is a little bit tricky, and I can explain what that is. So in HGA, it is possible to create one well that has multiple screens completed in the same well. This screen ID lets you differentiate between which screen you have taken the water level measurement for. For my data set that I'm working with for this project, I know that each well has only one screen, so I'm going to assign them all a default screen ID of 1. If I go back and open my water level data, all I have is a station name and a date and a depth to water level. So I am going to copy over station name, date, and depth to water. And then what I'm going to do is assign, as I said, all of these with a screen ID of 1. Now I'm looking at my lab data. Let's open that up. So in my lab data, again, I have stations and samples and the dates that those samples were collected. All of this is considered sample data, station name, sample ID, sample date. So let's put that in here. Now I don't have a lab ID or a batch ID, quality code, chain of custody, the quarter it was collected, or any comments, so I will leave those blank, because what I do have left is just the chemicals that were analyzed, the results, and the result units. So those are all stored in what we call the parameter result table. So once more, I will copy in the station. I will add the sample ID. Then I will add the chemical name, as well as the result unit and the result value. That is all of the data that I was working with, now all put together in this single Excel sheet. So I'm going to save this quickly and close it. And if I jump back to that quick checker, now this is where I'd exported that Excel template. What I can now do is invert that and choose to import from Excel. Here's that quick checker data file that I was working with. If I open that, now what I need to do is map the fields, but because I started by exporting from the quick checker, it tries to be smart, and So the destination are the quick checker fields that it wants, and the source are the column headers from the Excel sheet I was working with. And it will auto map any fields that have the same name. And in this case, that's pretty much all of them, with the catch that fields that have a numeric with a length unit or some other unit need to be manually mapped. But there are not too many of those, and they're pretty quick and easy to step through. Anything that's shown in green in these tables too, I should mention, these are the required fields. So at a bare minimum, if I had no other data in my lithology table, I would need to provide a station name and a depth from and a depth to in order to be able to import the record. All right, so that's all of my fields mapped. I can click OK. And now all of the data is shown inside the quick checker. Now I'd mentioned one of the nice things about working with the quick checker is that it will validate the data in this form before you go through trying to import it in Hydro GeoAnalyst. And it does that by checking the values against what it's expecting for that field. So in this case, you can see there's a red flag on the lithology tab. And over here on the side, under the errors list, it lists an error. So if I navigate to the lithology tab, the field that the quick checker is indicating has a problem has this little red exclamation mark in it. And it's telling me that 44.0 is not a valid number. And it looks like somebody has just made a typographic error and put in 2 decimals instead of 1. So when I edit that, you can see that the error goes away right away. And there's no other flags in the data set and no other errors listed on the side. So it looks like at this point the data set is relatively clean. If I click on the Validate and Submit button, it's double checking first that all of the data is in fact correct, and then it's asking for a file name. So I'm going to call this Ready for Import, and I will save it. That is the bulk import file all prepared and ready to go. Let me just save the raw file in case there's any problems that I want to go back to. I'll close the quick checker. If I scoot back into HGA, what I can now do is go through the bulk import process. So first we want to click on the import button, which is shown here. And we want to select this EDD format. I'll choose the EDD file, which I called Ready for Import. I'll open it up, and it does double check the records to make sure they're okay. And it's telling me a couple different things here. I am trying to import some data for some stations that do not exist. And I can choose at this point to actually add those stations to the project that I'm working with. I also, if I'm concerned that those stations might not be real stations, but maybe somebody has just made a mistake in the station name, I could reject those and export that data set of the rejected points out to a file and work with to figure out why they were rejected. For now, I'll go ahead and append them. And it's also telling me that there's some duplicate records and that those will be removed, and that's okay. That's actually very common when you take data that you have been managing in an Excel spreadsheet and then try to import it into a database that actually checks for duplicates and has some rules on that. This is a very common scenario. So again, it's telling me as it steps through each one of the data tabs that it's found some stations that I'm trying to work with that are not currently in the project. So I'll go ahead and say that I want to append those again. And you can see here now that it's checked all of the points around the EDD template that I was working with, and it's gone through for each of the data tabs that I was working with, the description add-ins, lithology, parameter sample, groundwater level, and parameter result. And it's verified that all of the data in them are correct. And I can go ahead and I can elect to import that data now. tells me that my import was successful at the bottom. If I close this and I jump back to the station list, go to the station data tab, I can now work with and see all of my lithology data. In a monitoring event, I can see the water levels. And if I jump out of the soil borings and go to those samples that had lab data, you can see all of the lab results and the parameters that were sent for each of the wells. There we go. We're officially ready to start working with our data in HGA.